Thank you very much. So I will
coming out. It's a 60-minute presentation in 30 minutes, so I'm going to have to kind of fly through it. Please hold your questions till the end. I'll hang out and answer whatever you have. Also, show of hands, who's familiar with cloud technologies? Okay. Who's familiar with containerization? Perfect. Okay, great. So, Brian Maganich, old school handle, Afex. Hit me up on Twitter. Dallas Hackers Association. Thank you very much for having me. We got Capital One people in the house. Thanks for coming out. So I'm going to jump right into it. We've been talking about cloud. Oh, wait a minute. Forgot. This is trademarked, by the way. Just like Cloud Bleed and Shell Shock and Heartbleed. And so it's yes, exactly. So we're going to be talking about cloud security first. So I'm gonna try to come in real high level, drill down as needed, but again, try to hold your questions till the end. So what is cloud? Does anyone know? Like in its simplest definition, what's cloud? Somebody else's computer. Exactly. So that too. That's a good point. That's a good point. So basically, in essence, cloud is it's virtual data centers, right? Everything's off-premise. There's varying degrees of that. We can get into that in a minute, but definition over there for you from our friends at Wikipedia. It leverages software-defined networking. If you're not familiar with that, it's basically pushing buttons rather than plugging wires. What else? A lot of them have managed and unmanaged services, and we'll get into that a little bit too. Basically, you have things like let's say IAM, Identity Access Management, or you have relational database systems, managed, unmanaged. There's different degrees of that. You got public, hybrid, private. You can probably tell what those are. Public's completely off-prem, hybrid, somewhat on-prem, somewhat off-prem, and private's completely on-prem. The advantages are it's cost efficiency. You can introduce automation into the environment itself, or you can integrate a lot of it into your continuous integration, continuous delivery pipeline. It's highly available. They are really, really well known for their high availability until S3. So all the things you want kind of in an environment, right? Agile, scalable, resilient to attacks. So that's why cloud's so popular. So jumping right into the architecture. Whoops, shit. I'm just going to go down here. So AWS architecture. First, I got to say I have no vested interest in AWS. I just work with it a lot. There's Azure. There's Rackspace, VMware, whatever. I just work with AWS a lot, so I know it pretty well. So basically, Amazon has these concepts called regions. Collectively, all of this would be Amazon, right? They have more than 2 regions. They span the globe. Within those regions, you have what they call availability zones, as abbreviated by AZ. So you got US West 1A, 1B, East 1A, 1B. Within those availability zones, we have what we call VPCs. We'll get into those in a second too. It stands for Virtual Private Cloud. So VPC 1, 2, 1, 2, they're different AZs. And the interesting thing about how software-defined networking and whatnot works is they can be in the same availability zone and whatnot. They can have overlapping address spaces until you peer those VPCs. So anyway. Yes?
Hey, the driver of a silver Scion, you're blocking 2 cars in. If you could please move your car so people can leave. Thank you.
All right, so real briefly, hopefully, VPC, a virtual private cloud. In the context of VPC, we have infrastructure as a services, I can't say it. Infrastructure as a service, or IaaS. So what I'm trying to depict over here is all the variations. So what we have on the left would be either completely on-prem data center, metal and up, or this relatively new concept is called MaaS, Metal as a Service. So it's off-prem, someone else's metal, but you actually get to go pick physical servers. So interesting evolution. The next one over is going to be, brain fart here. The next one over, I should have labeled them. The next one over is going to be IaaS, Server Hypervisor. Yeah, that's going to be IaaS. And we got PaaS. IaaS is on the right, I'm sorry. Anyway, moving on.
You made these all up just like...
Yeah, sure, right. Totally threw this together. So virtual private cloud, the important thing to point out here is that's the most basic construct of networking within Amazon AWS. So within virtual private clouds, you have subnets, gateways, firewalls, databases, virtual machines, containers. And we'll get into some of the managed services that help you manage those in a minute. So jumping right into security, this is some of the services they offer. Public key infrastructure through Certificate Manager and Cloud HSM. You can actually ship them a physical HSM and they'll plug it in and you can use it. Directory services, they have native Active Directory and LDAP. IAM, they have their own IAM system comprised of user groups, services. You can apply roles and policies to those. Audit logging for success denied, subject accessing objects. We have flow logs. Flow logs are basically accept, reject, firewall logging. You can get those from the EC2 or ENI, which is Elastic Network Interface level. One really cool thing that we worked on a few months ago was visualizing these flow logs, and you can do it natively within AWS. You enable flow log logging, you set up a log group, forward that log group to Elasticsearch, and then you can pump that index into a Kibana plugin, if anyone's familiar with Kibana. You can pump it in there and then go in and set up your graphs. Really, really cool stuff, right? It's kind of a pain in the ass to set up, honestly, but it is really cool. Yep. Sorry. Oh, I'm good. Yeah, thanks, man. And then authentication, I got an STS, simple token service, where you can get very short lifetime tokens to make API calls and whatnot in the AWS environment, forcing least privilege API access. Network, next layer down. You got routing, NAT, internet, and VPN gateways. There's some really interesting aspects of SDN and how NAT and gateways and VPNs work, so we can talk a little bit after this about that if you like. Scalability, we have what they call elastic IPs. It's basically on-demand scalable IPs. Again, SDN's a lot of advantages. We also have elastic load balancers. It'll scale out your instances. Application load balancers were just recently introduced. It's basically at layer 7. It's looking at different like images directory, CGI bin, whatever, right? It'll route it to a server accordingly. Again, resiliency. We got distributed DNS through what they call Route 53. Distributed content. It's a CDN. It's called CloudFront. There's so many of them. And then, most importantly, from a security standpoint, just kind of in a traditional means, we have network access control through NACLs. It's inter-subnet. It's stateless layer 3 packet filtering. We also have, and this is a evolution of those NACLs, is virtual host-based firewalls they call security groups. And we're really big on security groups. And the reason for that is, one, it's intra and inter-subnet. Second, it's IPv4 and IPv6 support. Layer 3, oops, there's a typo. Layer 3 and 4 layer, stateful packet filtering. You can do it at the interface and the instance level, so it just depends on how granular you want. So if you have an instance with 5 interfaces, but you only want to see that one, you can do it at the NI. And they're very modular and stackable. So you can have, let's just say you want one policy and one group and another one for the rule set to kind of cascade down to. You can stack those groups. Really cool concept. All right, storage. Snowball, Glacier, Elastic Block, Store. I mean, they're all encrypted at rest. I think is probably the biggest takeaway. They have varying degrees of use cases. Snowball is if you have petabytes of data and you don't want to upload it, they ship you a disk. You ship it back. It's encrypted. It's really cool. Glacier's online archiving. You can upload for free, but when you pull it down, one, it's slow. Two, it costs. So EBS, or Elastic Block Store, it's persistent block storage. Again, this is what most of your EC2s are going to use for their file systems and whatnot. Simple storage service. It's a generic object storage type. You've probably seen a lot of static content from websites hosted on S3, whether you know it or not. It's pulling off of an S3 bucket. You can work with RESTful API access on it. You can enforce its own ACLs, and you can implement at-rest encryption for those. Compute, this is kind of where Amazon originally got its start back in, I don't know what it was, 2005 or something, but 6, somewhere around there. We were oddly, right when it came out, we were generating rainbow tables on a few back in the day when I worked at McAfee, and we had a lot of fun doing that. Anyway, Elastic Cloud Compute, so that's your EC2. It's just a virtual machine. Amazon supports several operating systems, Ubuntu, Red Hat, CentOS, Windows 2003, 8, 12, 16 server. You have an Elastic Container Service. So when we get into containers, I'll just briefly touch on the orchestration and management of containers. Amazon offers their own. It's called ECS, Native Container Management. It scales out only. I want y'all to hold me true tonight, too, if I'm wrong on something. And then your Amazon machine images, and a lot of this really starts integrating really well into your CI/CD pipeline. We won't go into that probably tonight, but suffice it to say, it's an EC2 instant snapshot. Helps. There's a lot of advantages with like patching and deployment and whatnot. So it has its own native repository within AWS. Security practices. So it's not different conceptually than the real world, or whatever we want to call it, the matrix. But use identity and access management. Surprise, surprise, don't log in with your root account on AWS. There is a root account. Go in and create IAM users, roles, groups, policies, delegate them out, sign in with that account. It's just like logging in directly as root on Linux and Unix. Enable auditing, especially if it's more than you or you have an organization. You obviously want to have IAM logging and auditing enabled. You can enable multi-factor authentication. Google authenticators, what I use. You want to require any API keys for any API calls. You want to have unique keys, obviously, no different, and then use TLS whenever possible. Oh, so my little funny drawing over here is IAM plus Google Authenticator plus CloudTrail equals happy people. All right, we're already at container security. Where are we on time? Yeah? Good. Glad you asked. I put that quote up there for you. Oh, man, is it too small? So containerization, operating system level, server virtualization method in which the kernel of an operating system allows the existence, so on and so forth. A lot of people, including myself, just describe it as it's chroot on steroids. Everyone's familiar with chroot, right? So it's your jail environment. And it is in a sense, it is. We'll get a little bit into that. But what I like to compare it to, how many here has got like a compiled programming language background? You? Where's Russ? No Russ tonight? So, yeah. Oh. Okay, so. Yes. I don't know. Does Pascal compile? I guess it does compile. Anyway, okay, so. Basically, I guess I won't use the programming analogy then. You're basically, just think of it as a big tarball, right? You're taking all of the dependencies for Apache and MySQL and whatever else that you want to run as processes inside this container. You're going to tarball all that up, all the C libraries, the SSL libraries, blah, 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 all the dependencies. And you're going to tarball that up, and it's going to be about 200-300K, not very big. Depends on what you integrate into it, right? So what that enables you to do is move that around. It becomes very platform independent. So repository integration. So repositories are really important with one, code, but two, Docker and their images. So similar to the AMIs, right, the Amazon Machine Images, those are the images of the EC2 instances. The same holds true for Docker images in the same relation to the containers. Does that make sense? So the containers are similar to the EC2 instances in Amazon on that. Hope I'm not confusing with that. So what you do is you're going to be pulling down these images and firing them up, within seconds. That's one of the advantages of running containers. So GitHub, DocHub, they're the two most popular ones, and several more out there. Orchestration management, so Kubernetes and Mesos and whatnot, ECS for Amazon. When you have all these Docker containers running, right, you need resource management. You need to scale it out, scale it down, scale it up, scale it in, whatever. You need to be able to do that preferably in an automated fashion by setting some sort of threshold, like, my traffic rates increased this much, we're seeing this much throughput, spin out a couple more containers in EC2 instances. Go. There we go. Oh, wow. It's not going up there, man. It's not changing up there. Let me just try this.
Have you pressed enter?
Hold on, whoa.
I'm not pressing enter.
Way to put it on S3, Brian.
What
Yeah,
about
right?
this one? What about this one?
Okay, all right.
Something's
How
going
many
on.
freaking computers do you have up here? Where's my beer?
Obviously not enough. Where'd you put it?
I put it right here.
Give him a beer.
Is it up there again? There we go. Okay, something's weird, dude.
No.
Whiskey!
Whiskey. Hold on.
Wait.
No signal.
Is that the slide you were looking for?
I'll just be patient. We need to say a prayer real quick.
Dear Heavenly Cthulhu, we are gathered here to play.
What the fuck did you do to my computer?
I was standing down
I
there.
was sitting down there. I was like over here.
Is this what it feels like when a parent gets on their computer and their kids completely fucked it all up?
Yes! You're welcome to Reaper.
I asked them to come heckle me tonight.
Take him out.
It's comforting.
I'll be here for you. I know violence.
You got any shanks? Take them out. So Docker architecture, again, not promoting specifically Docker. There's other containerization technologies out there, but I'm just being as fully factual as possible. So you have you're going to see some similarities, right? This is a lot like Inception compared to, right? Have you all seen the movie Inception? It's like a dream within a dream within a dream. It's crazy, right? So you got a host OS that's physical. You can have Docker containers running right directly off of that. It's got a Docker daemon. It's command line utility. There's some GUIs that you can use, but basically you can run them on a physical host or within a virtual machine, the guest OS. So we'll get into a little bit of that on how you can use that to scale out certain things when you need to.
Are you running on Apple?
Yeah. Why?
I'm not going to stop.
Oh, okay, cool. So benefits, cost efficiency. These things are on demand, especially if you, one, incorporate them into your CI/CD pipeline, but two, if you're leveraging them in the cloud for scalability purposes, on demand, in and out, up and down. They're transient in nature. In fact, anyone here familiar with AWS Lambda functions?
It was off yesterday.
Right? I'm sorry? That was S3. Is Lambda down too? Oh. So, yeah. So you're familiar with Lambda functions, right? So my understanding, correct me if I'm wrong, Lambda functions, what they are is they're code. It's becoming, what is it called? Code as a service? Code as a, what's the latest word? Anyway, they're basically calling a Python, Node.js, Java function that you can define. and it spins up instantaneously and spins back down after whatever the execution's done. And you can do that like many times a second. You're being billed by the millisecond, so. Yeah, really, really cool. And that's a nice thing. You can have it come up, come down. Extremely transient, very cost effective. Very small memory and CPU footprints on the host OS and within the VM if applicable, right? Portable. It's host OS agnostic. I can run it on Mac, Windows, Linux. Works on my machine. How many times have we heard that, right? You got a problem come up, works on mine. Tough luck, dude. Mine too, dude. These now, you can just move them around. Very, very portable. Some of the security features of Docker. You have change logging, which is really good if you're doing incident response and one of your containers has been compromised. Shut the container down, do a diff on it compared to the image, and voila, you've seen what's changed. Really, really cool technique. Vulnerability management. Vulnerability management. I want to say it's a little stretch to say automated and clientless, but basically, if you're using repositories for these images, just as you would GitHub for code or whatever. When you go in and change that image, and you patch it, you rehydrate it, as we call it, right? That's what it's called, yeah, rehydrating instances. You go in and do that, and you just re-pull that image down to where the existing container is already running, right? Stop, start, boom. You've just patched all your environment. That's it. So that's where the orchestration and container management technologies come in, right? I patch my image for Apache, SQL, whatever. Save the image, push it to the repo, pull it down to all my EC2 instances that are running the containerized version of that image, spin the existing one down, pull that one up, voila, your entire environment's patched. Pretty cool, right? You can see the cost savings. You can see the security advantages of that, right? Isolation. So this is, again, Chroot on steroids. This is somewhat of a paradigm shift, but at the same time it's not. So they have isolated namespacing. And is anyone familiar with namespacing in the context of Unix and programming? So namespacing is basically, the easiest way to describe it is you have init, right? The first process. So let's just say in this magical world for some reason, you would actually have the same PID between what's in the container and what's on the host OS. They had the same PID, they could access the same resources. Previously, Docker has since changed that. They used to have shared namespace, and that was problematic for that reason. They've since isolated that within the last couple of revisions. They also have isolated user space, and that's kind of the heart of Chroot, right? You log in, you're bang. You can't get above / Now, where the security vulnerabilities arise is within the shared kernel space. So there's basically at the simplest level, going through kernel, right? Let me think about this. 3 ways to attack. So, I'm sorry? KFC? Yeah. KFC churches? Kernel? Cool. Kernel. Where was I? Yeah, 3 ways to attack kernel space. Yeah, so there's a vulnerability in the host kernel, right? If someone's on the container, since it's shared kernel space, they can attack that vulnerability and break out of the Chroot, out of the container. If there's a vulnerability in the container's shared kernel space, they can pop out of the container onto the host OS. Here's the really cool part. You got 2 containers sitting right next to one another, right? If there's a kernel vulnerability in the host OS, one container can exploit it and access the other container. Pretty legit, right? Pretty legit. I can't do it, but apparently you can do it. I'm sure Russ can do it. Russ probably figured out how to do it. He's probably the one, that guy's nuts. Jeez, that guy's nuts. Dropped 0 days like it's. All right, so obviously I just kind of covered a little bit of these. Short kernel space, increased attack surface. Some of the other, I don't want to call them anomalies, but it's just kind of a different way of thinking about things. It's difficult to secure these containers at layer 3 and 4. Here's why. When you're using containers, the objective really is to just maximize your efficiency of that virtualized or physical host, but in this case, virtualized host, right? Just as you're using a virtual machine to maximize the efficiency of the bare metal beneath it, right? Same concept. Well, when you start spinning up containers, you don't want to start spinning up one interface for every container, because now you're being charged for the use of multiple interfaces and so on and so forth, complexity, right? So what a lot of people do instead is they vertically stack those containers on one interface, and they'll start at, say, TCP 8000 for a website. Let's just say it's a simple website. They'll start up another exact container on 8001, 8002, 8003, and however many they need, right? Well, securing that through things like security groups, host-based firewalls within the containers, things like that, becomes problematic because of the scalability issue and whatnot. So suffice to say, from a layer 3 and layer 4, it's difficult to secure that. It's a very dynamic environment. And then at layer 7 as well, getting TLS certificate, X509 certificates on all these containers. Well, on one hand, you want to avoid issuing a wildcard to all your thousands and thousands of containers to you. That's bad, right? So what's the next best option? Well, issue certificates to each and every one, which kind of sucks too. So that's a problematic. There may be a way. I still have not looked into this. I think we talked about it last month at DC 214, but there may be a way to hook this into that cloud HSM where you can make API calls, provision certificates on the fly, give them a lifetime of a day, just let them expire. So there's some really cool options there. Poison images, again, repository. It is all your eggs in one basket. So it's highly available, but yeah, unless it's S3. Poor AWS. So poison images, if someone compromises the repository and puts malware onto one of the images, that could percolate throughout your entire environment. Bad thing, right? Compromised secrets, API keys, what have you. Sorry. All right, so security practices, just kind of going back and covering what I said. So the repository, restrict the least privilege and need to know. Just, security 101 kind of stuff, access control. Require API keys, or keys and TLS for API calls. So API calls are a little different if you're not familiar with how securing API calls, but you want to encrypt it at layer 7, or I'm sorry, 6 technically. Where's TLS operate? Let's just go with 6. And then so you want to encrypt and authenticate that connection, but you also want to have an API key that's used to authorize whatever call you're making, right? Can I put you on the spot?
Put him on the spot.
This gal here I work with at Cat 1 is working on a really cool project where she's scanning images for malware and stuff. Pick her brain. She's a really, really intelligent gal. Host. So on the host level, resource limiting with what Docker calls these C groups. And it's basically you can't pass the CPU memory disk write threshold, whatever, right? You can also go and do syscall profiling and whitelisting of applications, which is kind of cool. Always, if you have the patience to set it up, mandatory access control. Is everyone familiar with mandatory access control versus discretionary? So discretionary is what most people would see on like Linux, read, write, execute, read, write, execute, read, write, execute, right? Mandatory access control, whereas in discretionary, you're by default you have permission. Mandatory is truly least privilege in the sense that you don't get anything unless I explicitly say it, right? It's basically the difference. So SE Linux, probably the most popular implementation of Mac. Everyone's familiar with SE Linux?
Yes, what do you disable when you first install it?
Exactly, right? It's a bitch to install, but it locks. Mac is mandatory access control, I'm sorry. Yeah. And then, so I just learned of this today, and thanks to, yeah, this girl's sharp, man, I'm telling you. So I get an IM from this gal today, and she's asking me about this docker.sock. I was like, what the hell's docker.sock? So apparently, when you spin up these EC2 instances, or I'm sorry, Docker instances, the Docker daemon needs to know about different attributes about them, right? It does it through API calls, and it just to keep it clean and orchestrate everything, it needs information. Well, it does this through this Docker sock, and it's just an inter-process communication IPC channel that it uses. If you mount that, and I unfortunately don't remember the use case as to why you would want to, but if you mount that, there's ways for the containers to go through that IPC and access other containers. So, yes. It's IPC. I don't know if it's a named pipe or not. Google. Docker.sock named pipe. All right. DuckDuckGo, whatever. Thank you all for coming tonight.
Hey, give it up for all of our speakers tonight for coming up together. What do you got?
And for those who raised their hand on the multiple times we asked for the first timers, next month is your turn.
It's still
It'll
your
always
turn.
be your
It'll
turn.
always be your turn. It's fine. Hey, first night's free. Next month, step up and talk. What will you talk about next time? Thank you for coming for Dallas Hackers Association. Enjoy your time tonight. Cheers.
Not bad at all. Yeah.